Hi all of you. Very good evening. எல்லாருக்கும் வணக்கம். So this is SRT from KNA. So very welcome to our newly introduced online program NEET Premier League. NPL classes already running, going on. This is our new mission, a 20 days mission for training you peoples to crack NEET examination. And here today we are going to discuss one chapter from physics, and you can see here it is kinetic theory of gases chapter. So adukku munadi 2-3 things I want to share with you people. So we very happy news for you people. One thing is this year onwards Kerala NEET Academy providing classes through online platform also. That is why you are getting the free NEET training program during this period, and you know that it is a very short time period, and we will not go into in-depth discussion, but a short keys, shortcut methods, and a very useful concept from each and every chapter we are presenting here. And the NEET examination is very close to us. Don't be afraid, don't be tensed, don't be panic. Kerala NEET Academy ungoda kude irukku. We are always with you in every step of your preparations. And then NEET exam varumbodhu, physics part varumbodhu, நிறைய students they are expressing their concern related to physics. They are sharing their concerns like chemistry, physics, chemistry, biology part okay, almost okay. And a physics section varumbodhu, we are really struggling to solve the problem. We are spending more and more times in front of a single problem. Why it is happening? How we can overcome this one? So adukku oru solution mattum irukku. See, இந்த இடத்து ஒரு மேஜிக்கும் இருக்காது physics-ல. Purely scientific and systematic way to solve a problem. So if you are struggling in a particular problem, you are spending more and more time there, then adukku mainly two reasons irukku. The first reason is the lack of a scientifically prepared study material. Very important, crucial thing. Scientifically, systematically prepared study material. The second one is a proper training, because there are enough number of problems. Dharalama questions irukku physics-le. And adellam solve panna there are some tricks and techniques also there. So we need a proper training. So with a proper study material, scientifically prepared study material, and with a proper training, kandipa ungalku NEET exam clear panna mudiyum. So first of all, you have to develop such a positive confidence in your mind, and then very tactic approach, and days very fine days are there. And here see, physics problem solving வரும்போது, so different problem, different techniques we will apply. ஆனா இதோட எல்லாம் root same root. ஒரு சின்ன எக்ஸாம்பிள் പറഞ്ഞதுக்கு அப்புறம் we can start our today's section. See, when you are going for driving school, driving படிக்கிறதுக்காக உங்களை டிரைவிங் ஸ்கூலுக்கு போகும்போது அந்த இடத்த மாஸ்டர் உங்களை தூக்கி எடுத்து காருக்குள்ளே டிரைவிங் சீட்டில் இருத்தியதுக்கு அப்புறம் அந்த மாஸ்டர் சொல்லிக் கொடுக்குவே, இந்த இடத்து கிளச்சு, பிரேக், ஆக்சிலரேட்டர் இது எல்லாமே இருக்கு. அதெல்லாம் கிருத்தியமா கேட்டதுக்கு அப்புறம் you will try to use your brain and drive it. ஆனா டிரைவிங் படிச்சதுக்கு அப்புறம் you are not using the same car throughout your life. அதுக்கப்புறம் we will use more and different types of vehicles, but the techniques we are applying is the same thing. So that training, proper training, plus the way we are approaching the problem, this is very important. So yet the problem solve pannanalum there is only one technique, a technique root is just when you are getting a problem, we will be practicing that problem from this current chapter. Okay, kinetic theory of gases. So observation of a particular problem, a problem kandadukku appuram the reading and not merely simple reading, a thoroughly clearly concentrated reading, that is the first part of the problem solved. So the observation of the problem, first thing. Then secondly, proposal of a theory based on our reading. ஸோ ஒரு கான்செப்ட் கரெக்டாக உங்களுக்கு தெரியும்னா அது வாய்ச்சா மொமெண்டில் ரீட் பண்ணுன மொமெண்டில் தேர் வில் பி கான்செப்ட் இன் அவர் மைண்ட் ஃபார் எ குட் ஃபிசிக்ஸ் பர்சன்ஸ். அந்த தியரி வி ஹவ் டு செக் இட். இந்த இடத்திற்கு இந்த வேல்யூஸ் எல்லாம் சப்ஸ்டியூட் பண்ணியதுக்கப்புறம் வி ஹவ் டு செக் வெதர் இட் இஸ் ஒர்க்கிங். டெஸ்டிங் ஆஃப் த தியரி based on our proposed theory, testing of the theory. And finally, if the testing is okay, the problem solving and the edathu is over, fine, it is completed. Ana some higher order question varumbodhu we have to just modify the theory if needed. Avashyam irundha mattum we can modify it. These are the 4 steps, simple step for all problem solving from physics. Okay, so be cool and with a confident and happiest mind approach the problems. Only 4 steps. Reading, correct reading of the problem. Then immediately one idea should be illuminated in your brain. Adhe test cheyidadukapram every problem there will be a comfortable method. See, endha problemthil oru stopping point irundhalum kandipa andha edathu ஒரு key irukku and the problem. So 50% of the answer is there in the question itself. So you have to just tactically approach the problem. So, okay, so this is the thing I want to share with you. So don't get irritated by seeing the physics problems. Be happy and approach the problems, and definitely ungalala mudiyum. Okay, so now we can go to our physics part. NPL poite irika. You people are beautifully playing it also. ஃபிசிக்ஸ் பாட்டு வரும்போது மெக்கானிக்ஸோட இன்டராக்டரி பாட்டு கார்த்திக் சார் டிஸ்கஸ் பண்ணியிருக்கா. அதுக்கப்புறம் ஆசிலேஷன் வேவ்ஸு, தென் அபவுட் electromagnetic wave portion Agil sir discussed ചെയ്തിരിക്കുക. Then electrostatic portions Aslam sir discussed. Also some of the tricky questions and some shortcut keys from magnetism Prashant sir discussed ചെയ്തിരിക്കുക. Along with that NMN sir, PhD sir, different teachers are now handling the physics portions. And here today to our live section, again we are taking an entirely different portion, a new chapter in the eduthu koduthirika chapter kinetic theory of gases. So our main objective, do remember again and again I am telling, very short time effective tactic approach, and we want to clear NEET examinations. So in-depth derivations, nothing here we are included, but the needed discussions, content, everything are there. So every point whatever we are telling, take a paper and a pen and get ready for the class. Okay, I hope that we can right now start our classes. See, these much things are included here in the chapter kinetic theory of gases. The first thing about the summary of the chapter we will be discussing. A brief summary related main concepts and their relations, because kinetic theory of gases chapter varumbodhu previous year NEET question analyze cheyumbo you will be seeing that on the edathu some statement based question, direct equation related questions are there. So a very most probable chance to take score without any too much of risk. Okay, so only content thoroughly we have to move it. Second one, some of the expected questions also included here. And finally, for getting an idea, overall picture of the difficulty level of the chapter kinetic theory of gases, we included some of the previous years questions. This is the content today we are going to discuss. I hope that you people all are ready for the discussion. Fine. Then the first topic in the chapter we are going to discuss is gas laws. Correctly I am telling it is ideal gas laws. We are going to discuss about ideal gas laws. Ideal gas அந்த மாதிரி ஒரு கேஸ் இருக்கா? ஐடியல் கேஸ் ஒரு கேஸே இந்த உலகத்தில் இருக்காது. இந்த உலகத்தில் இருக்கின்ற ரியல் கேஸ் மட்டும். ஐடியல் ஹியூமன் பீயிங் அந்த மாதிரி ஒரு பர்சன் இருக்கா? அந்த மாதிரி ஒரு மனிதன் இருக்கா? ஐடியல் ஹியூமன் பீயிங் இருக்காது. ஆனா நம்ம மைண்டுக்குள்ளே சில கான்செப்ட் இருக்கு. இந்த மாதிரி கேரக்டர் எல்லாம் இருந்தால் டெஃபினெட்லி we will say he is as an ideal person, God, ideal person. Some characteristics are there in our mind. Okay, and right now here ideal gas. அப்போ அந்த மாதிரி ஒரு கேஸே இருக்காது. ஆனா இந்த மாதிரி கேரக்டர் எல்லாம் some characteristics மீட் செய்யும்போது அந்த ரியல் கேஸ் can be called as an ideal gas. ஆனா அந்த மாதிரி ஒரு ஐடியல் கேஸே இந்த உலகத்தில் இருக்காது. இஸ் a concept, is pure concept. உங்களுக்கு கார்னாட் என்ஜின் கேட்டிருக்கு. ஆனா கார்னாட் என்ஜின் ஒரு என்ஜின் இருக்காது. ப்ராக்டிக்கல் என்ஜின்ஸ் ஆர் petrol engine and a diesel engine. Anna Carnot and the scientist, he wrote some rules and regulations and some criteria. And that is an ideal heat engine efficiency is 100%. And the madri heat engine, practical heat engine. So here ideal gas. The gas, some of the basic rules and regulations are there, and the rules and regulations meet cheyyumbodhu, that is called an ideal gas. Fine. So but again I am telling and the madri oru gas ulagathil irukadu. We are dealing with the real gases. Fine. And the first ideal gas law we are discussing is about Boyle's law. So here in the ideal gas laws in the edathu we are discussing, simply we are discussing about behavior of gases. Gas eppadi behave cheyum, and some conditions provide cheyyumbo gas oda behavior, that we are discussing. So ungalku ideal gas equation theriyum. And ideal gas equation enna? Ideal gas equation na PV is equal to nRT is ideal gas equation. In the edathu P enna pressure, V enna volume, N enna number of moles, R enna universal gas constant, adoru constant, adoda value ungalku theriyum, R is equal to 8.31 joule per mole Kelvin. This is the value of universal gas constant. Above R already a constant, and T is the temperature. Now I am providing some conditions, and the condition kodukumbodhu the gas eppadi behave pannum. Let us see the first condition we are going to give. These are the conditions I am going to provide. Conditions. Let's check the conditions one by one. And the first condition I am going to given, this is the condition we are providing for a given mass of gas. For a given mass of gas. That is, mass is fixed. Mass fix na in the equation check cheyyumbodhu adile mass irukadu, ana n irukku. So mass fix na ungalku number of moles kandupidikkan oru formula theriyum. Oru gas irukkumbodhu oru definite mass of gas, let us say m is the mass of the gas. Gas oda mass m ana, and the molar mass, if it is m, then the mass of the gas divided by molar mass will give the number of moles. M is a mass of given gas. Adukulla etra mole irukka? N. Adukulla etra mole irukka ennu eppadi kandupidikkum? Mass of gas divided by molar mass eduthal podum. N. Appo molar mass of a gas already a fixed one value. M is right now I fixed. Then kandipa N is also fixed. So this is the condition. N again fixed. Appo PV equal to nRT already R, the quantity already a constant, and n also constant. Then the second one condition, this equation you have to remember for writing the state of ideal gas. Some problem varumbodhu number of moles and molar mass of gas related problems are there. So that relation you have to remember. And the second condition is this one, that is we are going to fix the temperature constant. Second condition, that is the second condition is temperature is going to be fixed. Second condition, temperature at constant temperature. Temperature could be constant akumbodhu, see right hand side nRT constant. How ideal gas right now behave? That is PV equal to a constant. This is the behavior we are getting when we are providing some conditions. Okay, first condition, gas is ideal gas. Okay, fine. Second condition, the mass is fixed and the number of moles also fixed. Third condition, temperature fixed. And you know the process is which process? Process is isothermal process. Okay, appo Boyle's law hold only for which process? The process is isothermal process. See, PV equal to a constant, or we can rewrite this as P is inversely proportional to V volume. This is the behavior of ideal gas under this condition. So Boyle's law states that for a given mass of, that statement is very important, for a given mass of an ideal gas, the pressure is inversely proportional to the volume of the gas, provided that temperature is a constant. P inversely proportional to V. Or problem solve the temperature constant ആക്കി വെച്ച് വരുന്ന problem വരുമ്പോൾ, and we can write the statement, if a gas system going from first state to second state, then we can PV equal to a constant, then we can write this as P1 V1 is equal to P1 V1 is equal to P2 V2. So this is the equation for Boyle's law when the process is isothermal process. So the first thing right now we are going to draw, next level is we are going to draw a PV diagram. Let us draw a PV diagram of this isothermal process. இந்த மாதிரி வரைக்கும் போது y axis I selected pressure P and x axis volume. See, pressure inversely proportional to Boyle's law, P inversely proportional to V. So volume കൂടുമ്പോൾ pressure decreases, and this is the behavior, and the shape of the graph is a rectangular hyperbola. And let us consider this is the PV diagram for a particular temperature, and let us take the temperature T1. T1 is a temperature. Fine. And again I am going to draw a PV graph for a higher temperature, T2. And let's see, this is the PV diagram for a higher temperature, T2. Let's see the graph. This is the graph, and this is the temperature T2, and here temperature T2 is greater than T1. And in the bold curve, the madri straight bold curve, it represents which gas? It represents ideal gas. And a real gas or behavior padichadekapparam real gas or plot good in the I am going to include. See, this is the plot of real gas. These two bold lines are PV diagram of ideal gas behavior. And the real gas varachidekapparam adoda data sheet check cheyumbo, you can see this thing. This dotted line represents real gas behavior. And see, this is the case. These two dotted lines, this dotted line represent real gas. And we are going to develop a very important conclusion. Very important conclusion. What is that? See, in the edit you can see the PV diagram of both ideal gas and real gas. I already informed real gas behavior, ideal gas behavior entirely different. And real gas ஏதோ ஒரு சிச்சுவேஷன் வரும்போது அது ஐடியல் கேஸாவே பிஹேவ் பண்ணும். எந்த இடத்து graph check ചെയ്യുമ്പോൾ you can see that separation, this separation, you can check this separation and this separation. எந்த இடத்து dotted line very close to the bold line. T2 temperature, higher temperature வரும்போது the real gas behaves close to ideal gas. So the first thing, real gas behaves close to ideal gas. First condition, at higher temperature. Fine, at a higher temperature. Second one, when you are seeing in the editha separation எடுக்கும்போது this is somewhat greater. ஆனா pressure கம்மியாகி வரும்போது you can check that the separation decrease, and இந்த இடத்தெல்லாம் the ideal gas and the real gas behavior is very, very close. So the first condition, okay, we discussed it. The real gas behave close, showing close behavior to ideal gas at a higher temperature. Second one, at low pressure. So you can remember like this: at a higher temperature and low pressure, real gas behaves as ideal gas. So you can remember like the HTLP. a shortcut form you can remember. High temperature, low pressure, the real gas shows close behavior to ideal gas, HTLP. Okay, high temperature, low pressure, fine. And here another one more value point I am telling, and we are concluding the Boyle's law here. In the slope edukumbodhu idu variable ah constant ah. See, slope constant avanana kandipa the graph should be a straight line. And in the straight line avadu slope change cheyidite So slope anna change in y coordinate dp divided by dv, and which is actually variable, not a constant variable. So only here this much points we have to remember. So finally, when we are saying under which condition Boyle's law hold good, three things: for an ideal gas at a constant temperature, moreover for a given mass of gas. Then these are the three conditions, and when we analyze the PV diagram, we can conclude that real gas shows a close behavior to ideal gas under two conditions: at high temperature and low pressure. This is it. Fine, only this much thing. So the final conclusion: P inversely proportional to V, or P1 V1 is equal to P2 V2, and Boyle's law hold good only for isothermal process. And then about the slope is variable, slope is not a constant, slope is variable, and the shape of the graph is rectangular hyperbola. And finally the very important conclusion, that is the real gas shows close behavior to ideal gas under constant under high temperature and low pressure. Fine. So this what about Boyle's law. And secondly about Charles law. So Boyle's law வந்தபோது உங்களுக்கு தெரியும் we provided some conditions. A condition check செய்தப்போ, so this is the behavior, ideal gas will behave like this. And again, for analyzing the Charles law, I am writing the ideal gas equation. What is ideal gas equation? Ideal gas equation na PV is equal to nRT. Fine, PV equal to nRT. In the R already constant, 8.31 joule per mole Kelvin. R value. That value you have to remember for solving problems. Okay. Then about again here I am given two conditions. First condition, the condition I am providing conditions. What are the conditions? Conditions kodutadukapram you have to tell me what is a behavior. Okay va? So first condition, for a given mass of gas, for a given mass of gas na mass fixed cheyumbo kandipa number of moles already fixed. Why? Because you know number of moles equal to mass of gas divided by molar mass. M fixed, in that the mass also fixed, N fixed. Fine, first condition. And the second condition is I am going to fix Boyle's law வந்தபோது at a constant temperature process, isothermal process, and இந்த இடத்து I am going to fix pressure constant at constant pressure. Pressure constant I fix cheyumbo, you can see that R a constant, N here constant as per our condition, and in the eduthu P also constant. Then what is the nature? What is the behavior under this condition? That is V proportional to T, and this is called Charles law. What is Charles law? For a given mass of an ideal gas, the volume of a gas is directly proportional to temperature, provided that pressure is a constant. அப்போ இது மாதிரி வரும்போது இந்த ஈக்குவேஷன் எப்படி சேஞ்ச் பண்ண முடியும்? V by T equal to a constant, or we can write V1 by T1 equal to V2 divided by T2. So Boyle's law discuss ചെയ്ത പോഴ് temperature constant ആയ പോഴ് P1 V1 equal to P2 V2. இந்த இடத்து pressure constant ஆய போது V1 by T1 equal to V2 by T2. So this is the relation. Boyle's law நடக்கணும்னா அந்த ப்ராசஸ் ஐசோதெர்மல் ப்ராசஸ். அப்படியான சார்ல்ஸ் லோ ஹோல்ட் ஹுட் அண்டர் விச் ப்ராசஸ் இந்த இடத்து ஆல்ரெடி ப்ரெஷர் கான்ஸ்டன்ட் ஆனால் that physical change is called isobaric process. So here the process involved is isobaric process. The process is isobaric process. And very importantly, now we are going to draw a graph and a very important conclusion. Adukapram I will be showing a problem, a previous year NEET question. That question you have to solve it and give me the correct answer. You can communicate me through the messages. Okay, fine, let us check. I'm going to draw a PV diagram. Let us draw the VT diagram. Volume, the diagram is VT diagram. VT diagram. Let us check the VT diagram. Volume is taken along y-axis. And temperature is taken along x-axis. And we already discussed the volume proportional to temperature under constant pressure. So graph வரைக்கும்போது directly proportional. Volume increase ஆகும்போ pressure temperature and volume increases shows a linear behavior. The volume of gas is directly proportional to absolute temperature. Do remember, here I am taking the temperature in Kelvin. Then only we can start the graph from origin, 0 Kelvin. Temperature 0 il varippo volume 0 anana 0 Kelvin, not degrees Celsius. Very importantly, not down. The graph will be like this when you are taking the temperature in Kelvin. And this is the VT diagram. This is actually this bold line represent which gas? Bold line. This is ideal gas behavior. And a real gas sort of behavior in the graph will varikumbodhu the real gas will be behave like this. See, this is the behavior. This dotted line represents real gas behavior. Very clearly you can see that எந்த இடத்து real gas will shows a similar behavior to ideal gas at higher pressure. Already we discussed HTLP. This is the condition when the real gas shows a close behavior to ideal gas at a high temperature and low pressure. Fine, I want to find out the slope of this VT diagram. Slope, that is very important one. Slope na ungalku theriyum. Slope na change in y coordinate by change in x coordinate. dv by dt is called slope, or tan theta ennu paranjalum podum. Slope is equal to tan theta. Slope na tan theta. Fine, we have the ideal gas equation. You know that it is PV equal to okay, fine. So let us check it. So here slope we have to find out. dv by dt we want to find it out. Okay, so the equation is ideal gas equation is PV equal to nRT. Correct. Just take the change எடுக்கும்போது எப்படி வரும்? pressure constant. அப்ப pressure change இருக்காது. P into dV is equal to nR into dt. nR and R are constant. P into dV is equal to nR dt. So இந்த இடத்துல dV by dt எடுக்கும்போது how it will change? So here P dV equal to nR into dt. So right now dV by dt is equal to nR divided by P. See, dV by dt is called slope or tan theta. Slope is inversely proportional to pressure. A very, very important conclusion. Slope is inversely proportional to the pressure. And then we can check a previous year question. This one, see, 2013 previous NEET question. Let us find out the answer. See the question in the given VT diagram. What is the relation between pressure P1 and pressure P1 and P2? What is the relation? And the P1, P2 pressure ellam koduthiruku. We have right now a conclusion. VT diagram eduthadukku appuram VT diagrathode slope is inversely proportional to pressure. We have a conclusion here. We have a conclusion here. Slope inversely proportional to pressure. So how we can solve this problem? Idoda meaning enna? Slope, the pressure slope jaasti irikumbodhu, then pressure will be less. Pressure கம்மி ஆயிருக்கும். அது மாதிரி ஸ்லோப் கம்மி ஆயிருக்கும் போது pressure will be more. Pressure will be more. And இந்த இடத்து when you are checking the slope of the two curves P1 and P2, the pressure P1 and P2, and the two graph எடுக்கும் போது this graph, the first graph when you are checking, அதோட ஸ்லோப் is very small. கிராஃப் y axis ஓட க்ளோஸ் ஆகும்போது ஸ்லோப் is increasing. ஹாரிசான்டலா இருக்கும்போது ஸ்லோப் is 0. So when it is moving, slope increasing and increasing. So which one is very close to y axis? This P2 is very close to y axis, which means that in the slope for this graph, slope is greater than the first one. So slope more anna adoda meaning pressure less. So which means that pressure P2 is less than pressure P1. So which option is correct one? Third option will be correct one. Third option. Okay, the slope of VT diagram is inversely proportional to pressure. So the curve P2 corresponding gas shows adode VT diagram slope is more than the pressure P1. So the slope more na pressure kammi aayirikum, P2 is less than P1, and it is fine. So this is the case. And then one more thing we have to discuss, that is this one. See, if the temperature is given in degrees Celsius, know how to draw the graph, how the graph will change. Volume VT graph temperature Kelvinil varumbodhu, no problem, it is starting from 0. This is 0 Kelvin. At 0 Kelvin, volume will be 0. But suppose I am going to take the temperature not in Kelvin, I am going to draw the temperature in degrees Celsius. V, and here this is temperature, it is in degrees Celsius. If the temperature is in degrees Celsius, see if the temperature is in degrees Celsius, then there will be a slight change. This is volume, and here it is the temperature, but it is temperature is in degree Celsius. Volume reduce ആയി 0 ആവണമെന്നാ 0 കെൽവിനിൽ മറ്റും വോളിയം 0 ആവും. 0 കെൽവിൻ എന്ന ഡിഗ്രി സെൽഷ്യസിൽ വരുമ്പോൾ ഡിഗ്രി സെൽഷ്യസിൽ എടുക്കുമ്പോൾ -273 degree Celsius corresponds to 0 Kelvin. அந்த இடத்து மட்டும் volume will be 0. So this is the graph. If you are taking temperature in degree Celsius, Kelvin varumbodhu it will be exactly starting from the origin. Here but I taken the temperature in degree Celsius. Fine. And in the edutha 0 degree Celsius il volume irukka, gas ku volume irukka, ethana volume irukku? V0 is the volume at 0 degree Celsius. Oh, here I want to find out y-axis volume at, generally this is the volume at T degree Celsius. T degree Celsius ulla volume kandupidikanna oru formula we have to develop it. This is a straight line. This straight line oda equation eppadi ezhudha mudiyum? Y is equal to straight line equation enna mx plus c, correct ana? Y equal to mx plus c is the equation of straight line. Appadina indha graph nokkumbodhu indha edathu m um c um idellam eppadi varum? C enna y intercept, this is c, y intercept. Okay, this is C, and V0 is the y intercept. And then slope is equal to change in y coordinate by change in x coordinate. This is y coordinate, that is V0 divided by x coordinate, and this much value 273. So when you are substituting the value, then y is equal to y enna volume at general at T degree Celsius. The at a temperature change agumbodhu generally y coordinate volume at T degree Celsius. Appo ee equation number 1 how it will be changing, that is y ke badala we can give Vt is equal to m ine badala V0 divided by 273 into x axis we took the temperature T plus V0. or I am rewriting the formula, volume at T degrees Celsius is equal to V naught plus V naught divided by 273 into T. So this equation you have to remember. Now 0 degrees Celsius ila volume eppadi kandupidikum? T ku badala 0 kodutha podum. So V0 equal to V0 degrees Celsius equal to V0 എന്ന് മറ്റും വരും. That is T is equal to 0. அப்படின்னா when T is equal to 1 degree Celsius வரும்போது how the volume changes, how the change will happen. So volume at 1 degree Celsius equal to V naught plus V naught divided by 273 into T க்கு பதிலா 1 degree Celsius. So this is the expression for volume. This is V at 1 degree Celsius equal to V naught plus V naught divided by 273. So how the change happens? So here when you are checking the change, for each degree rise in temperature, if the temperature is in degree Celsius, then for each degree rise in temperature, the volume எத்தனை increase செய்திருக்கா? 0 degree Celsius உள்ள வோலியத்தோட எத்தனை increase செய்திருக்கா? வோலியத்தோட 1 by 273 increases for each degree rise in temperature. So if the temperature is in degree Celsius, for each degree rise in temperature, the volume of a given mass of gas increases by 1 by 273. 1 by 273 of volume at 0 degree Celsius. Vt is equal to V0 divided by 273 into T. So this is the graph change when temperature is in degree Celsius. Fine. So with this we can conclude the Charles law also, second law also. Fine. So Charles law idellam എന്തെല്ലാം കാര്യങ്ങൾ റിമെമ്പർ பண்ணണം? The first one, the process is isobaric process, pressure constant. Then V by T equal to a constant, V1 by T1 equal to V2 by T2. Then about the slope, very importantly, Vt graph or the slope is inversely proportional to pressure, slope inversely proportional to pressure. And then about a graph, Kelvinil edukkumbodum degree Celsius edukkumbodum graph oda change. Very importantly, you have to note the change of the graph when it is in degree Celsius and the corresponding relation, Vt equal to V0 plus V0 by 273 into T. Fine. So now we can move to next, the third one, Boyle's law. Discussed at a constant Boyle's law discuss ചെയ്തപ്പോൾ condition we given Boyle's law at constant temperature and Charles law at constant pressure, the ideal gas behavior we discussed. And right now about the third one more law, that which is called Avogadro hypothesis. Let us check it. So first law discuss ചെയ്തപ്പോൾ the temperature constant, second law on the pressure constant, and in the edathu we are going to fix both the temperature and pressure constant. So the condition is this one. This is our condition. Condition is at constant pressure and temperature. At constant temperature and pressure, how the ideal gas will behave, constant temperature and pressure. See, we have the relation PV is equal to nRT. And in the pressure constant and temperature constant, you know that R is always a constant. Then the behavior will be volume proportional to number of moles or number of molecules. So we can write the conclusion, volume proportional to number of molecules. This is called Avogadro's hypothesis. So at a given pressure and temperature, at a constant temperature and pressure, equal volume of all gases contain equal number of molecules. So that meaning in a volume fixed ana, whatever be the gases, carbon dioxide, methane, whatever be the gases. For example, I am taking the three gas systems. In the 100 ml volume, I fixed the volume 100 ml, then here also 100 ml. And idukulle carbon dioxide, let us take it, carbon dioxide, idukulle ammonia, NH3, and then idukulle sulfur dioxide, SO2. Then suppose in the x number of molecules irika, how many molecules? X number of molecules. Then what is the number of molecules here and here? And this is the condition is provided, condition is at a constant temperature and constant pressure. Avogadro hypothesis, according to Avogadro hypothesis, equal volume of all gases, equal volume of all gases consist of equal number of molecules. அப்போ volume fixed ஆனா கண்டிப்பா இந்த இடத்து x ஆனா இந்த இடத்து x molecules, இந்த இடத்து x molecules, no doubt. Then again I am giving a problem. Let us try to solve this problem. Let us try to solve this problem. So in the edit, here I am taking a particular volume, and the volume is, here it is 50 ml is the volume. 50 ml is the volume, and we can take the molecule as oxygen. Maybe this is oxygen gas is included here, and then again the volume konjam kuda jastiya irukka indha edathu 100 ml is the volume. And let us take hydrogen. Okay, then again another one gas, and here the volume is, let us take 200 ml is the volume here. And here another volume, here I am taking 10 ml is the volume, 10 ml is the volume. And here also another gases, maybe methane, or another nitrogen, or any gases. Some gases are taken here. And in the edathe, let us take x number of molecules are here in 50 ml volume. Then how many molecules are here in the 3 volume? We know that according to Avogadro hypothesis, under constant temperature and pressure, the volume proportional to number of molecules. Adoda meaning volume constant ana, number of molecules also fine. Everywhere there we can take it as x. And in the volume is not a constant. So how to find out the number of molecules here? So you can write here, can find out the answer. See, in the x ana kandipa volume increase agumbodhu proportional to number of molecules, volume double agumbodhu, so here we will be having how many molecules? 2x molecules will be there. Then in the edathe, here will be 4x molecules, because 15 4 times volume increased, so number of molecules also 4 times 4x. And how many molecules here? And in the edathe volume konja kammi airika, 10 ml volume mattum irukku. So already this is given, this is our data, x molecules 50 ml volume, how many molecules? X molecules irika. Appadiyana 1 ml volume x by 50 molecules irika. Appadiyana in the 10 ml etra irika? 10 ml will contains x by 50 into 10, and it will be equal to 0 cancelled, x by 5. So in the edathe x by 5 is the number of molecules. So this is very very clear. Unit volume x by 50 irika, unit volume appadiyana 10 ml volume. So ஒரு சாக்லேட்டோட காஸ்ட் 10 ரூபி, அப்படின்னா 10 சாக்லேட்டோட காஸ்ட் 10 into 10. அப்போ யூனிட் வால்யூத்தில் இத்தனை மாலிகூல் இருக்கா, பட் கண்டிப்பா 10 ml வால்யூத்துக்குள்ளே x by 50 into 10, x by 5 is the molecules. So this is the way how you have to analyze the problems under constant temperature and pressure. So constant temperature and pressure, what is the relation? Equal volume of all gases contain equal number of molecules. This is the relation. Fine. So we are going to conclude the ideal gas laws here. First we discussed about Boyle's law, different points, and Charles law, then about finally Avogadro hypothesis. Fine, then we can check one more question. Here you can check the question and let us find out the answer. The number of molecules in 10 ml, the number of molecules in 10 ml of each O2, NH3, CO2 at STP, check it at STP, standard temperature and pressure in the water. Volume for O2, NH3, CO2, the volume is same 10 ml. What is Avogadro hypothesis? What is Avogadro hypothesis? At STP, standard temperature and fixed pressure fixed. Under this condition, equal volume of all gases contain equal number of molecules. So the order is NH3 will be equal to number of molecule NH3 equal to CO2 equal to O2. So the correct option is third one is the correct option. Fine. So then now we can go to next another one question. Let us check the question. What is the question? The equation for state of 5 gram of oxygen at a pressure P and a temperature T when occupying a volume will be. What is the state of oxygen? Condition given 5, mass of gas is already given as 5 gram and P is the pressure, T is the temperature, and it occupies in volume V. Appadiyana, we want to find out the equation of state. Equation of state enna? You have the equation of state. Equation of state is PV is equal to nRT is the equation, ideal gas equation of state of a gas. In the option check PV equal to left side PV. Okay, fine. So RT also all option so we want to very logically simply reading, you can see that N we have to modify, N we have to find it. N order value kandupidichina problem already solved. So how to find out the number of moles? Very important. Boyles will discuss cheyidapodum, Charles will discuss cheyidapodum. I informed how to calculate number of moles, not molecules, number of moles. If M is the given mass of a gas, then adukulla ethana moles irukka adu kandupidikkanona mass of gas divided by molar mass adukulla etra moles irikkannu kandupidikkanona mass of gas by molar mass. Fine. So here mass of gas is given as 5 gram. This is 5 gram. And then about molar mass we have to find it out. Molar mass. So mass of gas divided by molar mass. What is the molar mass of? You can find out the value of molar mass also from there, and then directly the answer will be there. Answer is there. Okay, mass of gas divided by molar mass. Oxygen, it is given as oxygen or molar mass, it is 32. So divided by 32 gram. Gram il kodithal podum because numerator denominator same, convert pannanilla. Simply, so 5 by 32 is the value of smaller tree. So state will be equal to PV is equal to N in badala 5 divided by 32 RT is the correct answer. So here it is missing. So see this option we have to modify. PV equal to the mistake 5 divided by 32 RT is the correct answer. 5 divided by 32 RT is the correct answer. Okay. So this is the state. PV is equal to 5 by 32 RT. Fine. Okay. Then about the next one topic, density of ideal gas. This related some questions also we have to develop, and the relation for density of gas. Density கண்டுபிடிக்கணும்னா உங்களுக்கு ஒரு basic formula தெரியும். Density ஓட basic formula. Density rho is equal to mass divided by volume. This is called density. We want to develop a mathematical equation for density. So in the equation we have to start from the ideal gas equation. What is the ideal gas equation? Ideal gas equation is PV is equal to nRT is the ideal gas equation. And in the volume irukku ana mass irukadu. So we have to include mass here. How to include mass? Mass kandupidikkanona you have the relation for n. Small letter n enna അത് number of moles കണ്ടുപിടിക്കണമെന്ന mass of gas divided by molar mass into RT. So இந்த இடத்த mass இருக்க, the volume இந்த இடத்து இருக்க, take it in the right side, you will get m divided by v is equal to, இந்த m எடுத்து ലെഫ്റ്റിൽ പോകുമ്പോൾ പി ക്യാപിറ്റൽ എം ഡിവൈഡഡ് ബൈ ആർ ഇൻറ്റു ടി. இந்த இடத்து സ്മോൾ എം എന്ന മാസ് ഓഫ് ഗ്യാസ്, ക്യാപിറ്റൽ എം എന്ന മോളാർ മാസ്. സോ മാസ് ബൈ വോളിയത്തിക്ക് ബദല we can give rho, density. That is density we calculated as density rho is equal to pm divided by RT. So this is the one of the relations for density of ideal gas, pm divided by RT. And one more equation we are going to develop, that is molar mass. You know that 1 mole of an ideal gas contain Avogadro number of molecules. So if m is the mass of one molecule, within this 1 mole of gas, how many molecule? It contain Avogadro number of molecules. That is molar mass equal to mass into Avogadro number. This small letter m is the mass of one molecule and Na is the Avogadro number, and this is called molar mass. Idukulle 1 mole of an ideal gas contains this much molecule, Avogadro number of molecules. So then we can substitute the value here. Small letter m ine badala value kodukumbodhu, small letter m ine badala value kodukumbodhu, now this equation will change. Density rho is equal to P into capital M ine badala small letter m into capital Na divided by R into T. See, I am going to do a small arrangement like this. Na could I am taking to the denominator, then P into small letter m divided by R divided by Na Avogadro number into T. உங்களுக்கு தெரியும் யார் R by Na னா gas constant R divided by Avogadro number is called Boltzmann's constant, Kb, Boltzmann's constant. So this will become density rho is equal to P into small letter m divided by Kb into T. So I am telling just a method to remember this relation. See, இந்த இடத்தை செக் செய்யும்போது P capital M divided by RT. ஆனா இந்த இடத்து வரும்போது அது P small letter m divided by Kb into T. Capital M உங்களுக்கு யாருன்னு தெரியும், அது molar mass. Small letter m ன்னா mass of one molecule. அப்போ எந்த இடத்தை capital M மாறி small letter m ஆகும், கண்டிப்பா அந்த இடத்தை R சேஞ்ச் பண்ணி எது கொடுத்தால் போதும், Kb கொடுத்தால் போதும். So this is the two relation you have to remember in your mind. Density of gas, two formula. First one formula, what is first formula? That is Pm divided by P capital M divided by RT. Then I already informed எப்படி capital MR is small m ஆகும்போது this R will be changes to, yes, I am writing here, let us check. Density formula we derived as P capital M divided by RT, or this will be equal to one more formula in terms of Boltzmann's constant, that is P into capital M R small letter m ஆகும்போது R change ஆகி it will be Kb into T. எந்த இடத்து capital M molar mass change ஆக்கி இந்த மாதிரி change பண்ணி mass of one molecule கொடுக்கும்போது கண்டிப்பா R must be changed to Kb. So these are the two relations. What are the relations? Density of ideal gas is P capital M divided by RT, or P small letter m divided by K into T. So this is about the density of gas. And now let us try to solve one problem. This is the one question. Try to solve the problem. This is the case. Two vessels separately contains two ideal gases, and the first one is A and the second one is B. Two ideal gases at the same temperature, and it is given that the condition at the same temperature. The pressure of A being twice that of B, and under such conditions the density of A is found to be 1.5 times the density of B, then the ratio of molecular weight of A and B is. try to read the question one more times. Two vessels separately contains two ideal gases A and B at the same temperature. The pressure of A being twice pressure of A, given data, pressure of A, given that pressure of A being twice that of B, pressure of A being twice that of B. Under such a condition, the condition varumbodhu, then one more thing, the density of A is found to be 1.5 times density of B, and these are the two things given here. These are the given data. What we want to find out, actual question enna? Question, what is the ratio? We want to find out the ratio. And a ratio of weight of molecular weight of A and B. That is, we want to find out molecular weight of MA divided by molar weight of B, MA by MB. This ratio we want to find out. So we identified the problem. I already informed. Or problem solve pannanuna first correct observation of the problem. Okay, and we observed and we identified the problem and proposal of a theory based on our observation. ஏதாவது ஒரு ஐடியா வரணும், அவனோட மூளைக்குள்ள ஒரு ரிலேஷன் கண்டிப்பா இன்ஸ்டன்டாவே வரணும் இது சால்வ் பண்ண. எது ஃபார்முலா உங்களோட மைண்டில் வந்திருக்கா? எது ஃபார்முலா? density എന്ന് പറഞ്ഞിരിക്കും, pressure എന്ന് പറഞ്ഞിരിക്കും, molar mass, density just we discussed about density of ideal gas. And two relation இருக்கு அந்த இடத்து. density கண்டுபிடிக்கணும்னா two relation. What are the two relation? First one, rho is equal to P capital M divided by RT, one formula. Or we already I informed one more formula, that is P into capital M change I small letter m ஆகும்போது R மாறி it will be KB Boltzmann's constant into T. And the second relation oda need irukadu indha edathu, because we want to find out ratio of molecular weight MA by MB. We have to find it. Okay, fine. So we decided, we proposed our theory, we proposed our relation. This is the relation we want to use to solve the problem. So I selected one. This is the second step of problem solving. Then testing of the equation, we have to find out, we have to substitute the values here. If the problem is we are getting correct answer na and edathu we can conclude, and that is our answer. If anything, if there is no correct answer, then we have to modify it. Okay, first we can believe that it will works and just try to find out the answer. 0. இந்த இடத்த கொஸ்டின்ல ஒரு கண்டிஷன் ஆல்ரெடி இன்ஃபார்ம், எந்த ஒரு கொஸ்டின் எடுக்கும் போதும் அதுக்குள்ளே ஒரு 50% ஆன்சர் அதுக்குள்ளே இருக்கா கண்டிப்பா. ஸோ இந்த இடத்த ஒரு கண்டிஷன் கொடுத்திருக்கு. என்ன கண்டிஷன்? டெம்பரேச்சர் கான்ஸ்டன்ட். ஆல்ரெடி தே இன்ஃபார்ம்டு டெம்பரேச்சர் கான்ஸ்டன்ட். அப்போ T ஆல்ரெடி கான்ஸ்டன்ட் and R already constant. அப்படியானா டென்சிட்டி எந்த மாதிரி எழுத முடியும்? டென்சிட்டி ரோ proportional to PM ன்னு எழுத முடியும். கரெக்ட்? PM. Fine. So then we want to find out MA by MB. So I am taking the ratio like this. Rho A by rho B எப்படி எழுத முடியும்? Rho A by rho B na PA into MA divided by PB into MB. This is the relation. And here we want to find out this one, MA by MB we want to find out. And the question directly given that rho A equal to 1.5 times rho B. So change is rho A ke badala 1.5 times rho B ennu koduthiruku. All divided by rho B is equal to PA is equal to already given us 2 times PB ennu koduthiruku question into MA. We can keep there, and divided by how it will become, then divided by PB adu madriye koduthu into MB. See, PB cancelled, rho B cancelled. Then what will be this one? MA divided by, it will be equal to MA divided by MB is equal to what? Change we have to do it, just take the 2 in the denominator, just take in the denominators. Then how it will become? MA divided by, see, let us work here. See, MA divided by MB is equal to 2 லெஃப்டில் வரும்போது 1.5 ஆல்ரெடி அந்த இடத்து இருக்கு 2. திஸ் இஸ் அவர் ஆன்சர், திஸ் இஸ் அவர் ஆன்சர் 1.5 டிவைடட் பை 2. ஆனால் அந்த மாதிரி ஒரு ஆப்ஷனே அதுக்குள்ளே இருக்காது. ஸோ see the last step is coming. So what is the method of problem solving? See you have to believe physics, you have to believe the scientific method, only for a method. Any problem even in life or even in our physics, same method. Identified the question, first we identified this is our problem. Secondly, we proposed a particular equation for solving the problem. Second phase is also okay. Then we are going to test it. Okay, I given the values and I tested, fine, I got an answer. And right now option check ചെയ്യുம்போது அதுக்குள்ள அந்த மாதிரி ஒரு ஆப்ஷன் இருக்காது. So what we want to do, just a modification if needed. ஆனால் இந்த இடத்து ஒரு மாடிஃபிகேஷன் வேணாம். என்ன மாடிஃபிகேஷன் வேணாம், இது எது மாதிரி சேஞ்ச் பண்ண முடியும்? சி இது நம்மளோட ஆப்ஷன் செக் செய்யும்போது இதுக்குள்ள ஒரு 3/4 இருக்கு, அது இது மாதிரி மேட்ச் ஆன ஆப்ஷன். சி இந்த இடத்து நியூமரேட்டர் டினாமினேட்டர் 2 കൊണ്ട് மல்டிப்ளை ചെയ്യുമ്പോൾ how it will become 1.5 into 2, 1.5 or a double, that is equal to 3 divided by 2 into 2, 4, 3/4 is our answer. So the correct option is third option, correct. So okay, fine. So while we are moving, we have to recollect all the terms from the beginnings. Remember Boyle's law conditions, Charles' law conditions, Avogadro hypothesis condition, very importantly HTLP. Real gas behaves close to ideal gas at a high temperature and low pressure. And the graph analysis then VT diagram, the slope is inversely proportional to pressure. So recollect fastly. And then density of ideal gas, this is the formula, rho equal to Pm by RT or P small at m by kBT. Fine, this is okay. Now we have to, just for a comparison, one previous year question in the either topic related irundirika. Okay, appo idu one just we can just analyze this one. Okay, that is ideal gas and real gas. A comparison, a small comparison. Okay, I hope that you people are coming along with me, and whatever being the value point, you have to note in between. Okay, ideal gas and real gas. Let us check the ideal gas equation. The ideal gas equation is what is ideal gas equation? PV is equal to nRT. PV equal to nRT for 1 mole of an ideal gas. For 1 mole we can write PV is equal to, simply we can write RT for ideal gas. This is ideal gas equation. Okay, not real gas equation, ideal gas equation. Okay, அப்படினா இது RT கூட லெஃப்ட்ல வரும்போது எப்படி ஆகும்? இது PV by RT equal to a constant. PV by RT equal to a constant, not a constant, simply PV by RT equal to 1. Correct. PV by RT is equal to 1. 1 ன்னு எழுதணும்னா கண்டிப்பா only for PV by RT one value, it is only for which gas? Only for ideal gas. Right now I am going to draw a graph. Let us analyze the graph. அதுக்கப்புறம் அந்த graph வரைச்சதுக்கப்புறம் I will ask you a question. அது உங்களுக்கு கரெக்டா ஆன்சர் பண்ணணும். Okay, let us check it. இந்த இடத்து y axis I am taking PV divided by RT. This PV by RT I am taking in the y axis, and then I am taking pressure P in the x axis. And you know that PV by RT value നമ്മൾ കണ്ടുപിടിച്ചിരിക്കാ. It is 1/4, always 1/4. It is always 1/4 ideal gas. About see here it is 1. Let us take 1, and this bold line represent always 1 for ideal gas. PV by RT is always 1 for which gas? It is always 1 for ideal gas. Okay, fine. Okay, and real gas ode graph ode idakulle I am going to include real gas graph. I am going to draw 2 graphs. You have to identify the 2 graphs. See, in the one graph, just as consider, this is the real gas graph, dotted line, and this is at temperature. Let us take it as temperature T1, and then one more graph. This is the second one, and this is at a temperature T2. This is at a temperature T2. This is the graph. You have to inform. You see, on the bold line, white line, it represents ideal gas, no problem. And these two things, T1 and T2 temperature, these graphs are not for ideal gas. This is for which gas? This is for real gas. This is for real gas. Two things are for real gas. Fine. Then my question is, which temperature is greater? T1 greater than T2 or T2 greater than T1? Which is one is correct? Which one is correct? And both are for real gases, and this one is only for ideal gas. What is your opinion? What is your opinion? See, we have a condition. This is the condition, HTLP. A real gas behaves, real gas shows close behavior towards ideal gas under high temperature and under high temperature and low pressure. See, in the ideal gas oda pakkath varanona, close ஆகி வரணும்னா அது கண்டிப்பா at a higher temperature. So at a higher temperature only, this graph is very close to this one, ideal gas. So this T2 must be greater than T1, because real gas, both are for real gas. These two graphs are for real gas, and the temperature at a higher temperature only, the real gas shows a close behavior to ideal gas. So since it is this curve is very close to our ideal gas curve, so the temperature T2 is greater than T1. So this is the comparison between ideal gas and real gas. And see, the y-axis, all the graph meet at a common point in the y-axis. So many statements will be given from this graph. See, first one, which of a graph, a plot between PV by RT and P is given in the diagram. Following statement, consider the following statement and find out the wrong statement. T1 greater than T2, T2 greater than T1. The bold line represent, the white one represent ideal gas behavior, and both all the curves meet at the same point on the y-axis. These kind of statement will be given. So temperature wise analysis நடத்தும்போது we will find that T2 is greater than T1. So அந்த மாதிரி ஒரு ஐடியா இருக்குன்னா we can easily find out the right and wrong statements. Okay, fine. So then about next one, about kinetic theory of ideal gas. There are 11 postulates. The postulate statement based question may be there. So we have to definitely go to the NCRT text order, crush your core point. The 11 point here I am including, and the 11 points are important, that are called the kinetic theory of gases postulates. The first postulate, kinetic theory of gases. You are knowing very clear, similarly as you know from even in chemistry you already learned. Okay, so kinetic theory, the first postulate of kinetic theory is a gas consists of atoms and molecules. A gas consists of atoms and molecules. Definitely atoms and molecules, one by one connected thread is there, and the madri pogumbodhu you can easily remember molecules. Then second point, so first one, a gas consists of atoms and molecules. Then the molecules of same gas are, the madri molecules irka gas kulla molecules irka, molecules of same gas are identical in all respect. enna endha edathittu 3 beaker eduthathukku appuram oxygen molecule eduthu vekkumbodhu endha eduthu poyalum oxygen molecule irka, all places oxygen molecules. If the gas is same, then the molecules are identical in the sense that their mass is same, their size is same, their shape is same. So molecules of same gas, molecules of same gas are identical in all respect. Identical means identical in mass, identical in size, identical in shape. So this is the second postulate. And then about the third one, the third postulate. Third. And since the molecules in a gas are in random motion, constantly random motion along a straight line. So the molecules are constantly in random motion, along a straight line, So only straight line motion we will be considering, not vibration, not rotation, only we are considering straight line motions. The molecule are constantly in random motion along a straight line. Then about another fourth one. See, kandipa, இந்த மாதிரி molecule when they are in random motion, next postulate, kandipa they will collide with each other. And the collisions are perfectly elastic in nature. All the collisions of molecules are perfectly elastic in nature. Elastic nature na adoda meaning enna? Perfectly elastic in nature na kinetic energy is conserved. Elastic collision, you know that kinetic energy and momentum will be conserved during these collisions. That is, initial momentum is equal to final momentum. Initial kinetic energy will be equal to final kinetic energy. So the collision is perfectly elastic in nature. Fine. Then about the fifth, another one point. See, while the molecules are colliding with the walls of the container, if you are taking a gas system, the molecules are there, and during the random motion, the molecules may collide with the walls. And while they are colliding, they exert some pressure. So the pressure of a gas, ஒரு கண்டெய்னருக்குள்ள இருக்கும்போது ஒரு pressure இருக்கா gas. The pressure of a gas is due to the collision of the molecules with the walls of the container. That is, pressure will be proportional to number of collisions. Pressure is proportional to number of collisions per unit area. The pressure of a gas is due to collisions of the molecules with the walls of the container. So we can write pressure is proportional to number of collisions per unit area. Then about the next sixth point. While the molecules are in random motion, they may have kinetic energy definitely due to the motion. The kinetic energy of gas molecules depends only and only on absolute temperature. Absolute temperature and temperature in Kelvin. When the temperature is 0 Kelvin, definitely kinetic energy is also 0. Kinetic energy is not 0 at 0 degrees Celsius. Degree Celsius വരുമ്പോൾ ആ VT ഡയഗ്രത്തോടെ ഒരു ചേഞ്ച് വി ഡിസ്കസ്ഡ്. വോളിയം നോട്ട് 0 at 0 degree Celsius, 0 Kelvin மட்டும் வால்யூம் 0. அது மாதிரி kinetic energy not 0 at 0 degree Celsius. That is why I informed the kinetic energy of a gas molecule depends only and only on absolute temperature. That is temperature in Kelvin, absolute temperature. At 0 Kelvin, kinetic energy will be 0. Definitely kinetic energy is 0. Okay, fine. So then about the seventh point, next point. The actual volume. See, ഒരു ബീക്കർ ഒരു സെഗ്മെന്റ് ഒരു വോളിയം എടുക്കുമ്പോൾ ഇതിക്കുള്ള ഗ്യാസ് മോളിക്യൂൾസ് ഇരിക്കുക. they are spaciously arranged. This is the volume occupied by the gas molecule. ஆனால் இந்த molecule எல்லாவரையும் எடுத்து ஒரு சின்ன இடத்து கொண்டு வரும்போது, எல்லா moleculeயும் எடுத்து ஒரு இடத்து கொண்டு வரும்போது இத்தனை வால்யூம் தேவையில்லை. இந்த மாதிரி all molecule when you are placing the 5 molecule எடுக்கும்போது, this is called actual volume. This is the volume occupied. So what is the concept? The actual volume of a gas molecule is negligibly small as compared to the volume occupied by the gas. Okay, actual volume is negligibly small compared to the volume occupied by the gas. Then about next point. There is no intermolecular force of attraction between the molecule. IDS, these are the postulates of postulate of kinetic theory of ideal gas. Ideal gas ആണ് already informed ideal gas എന്ന് മാതിരി ഒരു ഗ്യാസ് ഉലകത്തിൽ ഇരിക്കാതെ ana இந்த மாதிரி characteristics എല്ലാം obey ചെയ്യുമ്പോൾ we will call it as an ideal gas. Ideal gas. So here there is no intermolecular force of attraction among the molecules. So the next point, there is no intermolecular force of attraction. There is no intermolecular force of attraction among the molecules. அதோட மீனிங் என்ன, வெரி இம்பார்ட்டன்ட். அந்த இடத்துல கான்செப்ட் இருக்கு. உங்களுக்கு தெரியும் இன்டர்னல் எனர்ஜின்னு ஒரு கான்செப்ட் இருக்கு. இன்டர்னல் எனர்ஜி இஸ் ஆக்சுவலி த சம் ஆஃப் கைனட்டிக் எனர்ஜி அண்ட் பொட்டன்ஷியல் எனர்ஜி. ஐடியல் கேஸ் எடுக்கும்போது தே ஆர் இன் ரேண்டம் மோஷன், டெஃபினட்டாகவே கைனட்டிக் எனர்ஜி இருக்கு. ஆனால் இன்டர்மாலிகுலர் ஃபோர்ஸ் ஆஃப் அட்ராக்ஷன் இருக்காது. ஸோ இஃப் யூ வாண்ட் இன்டர்மாலிகுலர் ஃபோர்ஸ் ஆஃப் அட்ராக்ஷன் இருந்தால் மட்டும் வி வாண்ட் டு டூ ஒர்க் எகெயின்ஸ்ட் இன்டர்மாலிகுலர் ஃபோர்ஸ் ஆஃப் அட்ராக்ஷன். அந்த மாதிரி ஒர்க் செய்யும்போது it will have a potential energy. ஆனா இந்த இடத்து intermolecular force of attraction இருக்காது. அப்ப we don't want to do any work. அப்ப potential energy இருக்காது. So the internal energy of ideal gas is completely in the form of kinetic energy. Internal energy is in the form of kinetic. ஆனா real gas எடுக்கும்போது intermolecular force of attraction இருக்கா? அப்ப internal energyக்குள்ள kinetic energyயும் வருவே, அந்த இடத்து potential energy இருக்கு. ஆனா ideal gas எடுக்கும்போது there is no intermolecular force of attraction, so definitely internal energy is in the form of kinetic energy. Then ninth point, the next postulate, that is gravity is neglected. Gravity has no influence in the ideal gas. Gravity is neglected. Gravity has no influence. And the 10th point, the molecules are எப்படி இருக்கு, the molecules, so gas molecules, the molecules are tiny rigid spheres of negligible volume. Molecules are tiny rigid spheres of negligible volume. See, volume negligible na volume 0 na 4/3 pi r cube. Radius 0 na அதோட மீனிங் rotational kinetic energy உங்களுக்கு தெரியும், half I omega square. Radius 0 na கண்டிப்பா moment of inertia I is equal to mr square. Moment of inertia will be 0 because r is 0, negligible volume வரும்போது. So rotational kinetic energy will be 0. So rotational kinetic energy இருக்காது, rotational degree of freedom இருக்காது. Only translational degree of freedom is there for such molecules, gas molecules, since it is negligibly small volume. Okay, so then about last point, at absolute zero na 0 Kelvin. At absolute zero, you know that kinetic energy is 0, because we have discussed this postulate. Kinetic energy depends only on absolute temperature. At 0 Kelvin kinetic energy will be 0. Kinetic energy 0 means all molecular motion will stop. So this is the condition. At 0 Kelvin molecular motion stop. Molecular motion stops. So these are the 11 postulates of kinetic theory. So statement wise question எந்த இடத்துல ചോദിക്കുம்போது உங்களுக்கு just to recollect one by one properties, one by one postulates in your mind. See, gas consists of atoms and molecules. Molecules of same gases are identical in all respect in mass, size, shape. Then the molecules are constantly in random motion along a straight line. And the collisions of molecules are perfectly elastic. Momentum and kinetic energy conserved. Then the pressure of a gas is due to the collision of the molecules with the walls of the container. Pressure proportional to number of collisions per unit area, and the kinetic energy depends only on only on temperature. Then actual volume is very small compared to the volume occupied. There is no intermolecular force of attraction, gravity neglected, and the molecules are tiny rigid spheres of negligible volume. So then அந்த மாதிரி எடுக்கும்போது rotational degree of freedom is avoided. Okay, and then at 0 Kelvin the molecular motion will stop. This what about postulate of kinetic theory of gases. Then about a kinetic gas equation. Kinetic gas equation, a very important core part of the chapter, that is kinetic gas equation. അപ്പോൾ കൈനറ്റിക് ഗ്യാസ് ഇക്വേഷൻ ഇനി இந்த மாதிரி പോകുമ്പോൾ ഇതെല്ലാം the remaining thing entire things depends upon kinetic theory, postulates of kinetic theory. അതുക്കുள்ள one by one we are taking and going for a detailed discussion. So very important, note down, very important one, that is kinetic gas equation. Kinetic gas equation. Kinetic gas equation. Let us check what is kinetic gas equation. Kinetic gas equation, it is an equation for, see, the pressure while the gas molecules are in motion, they will exert a pressure. They will exert a pressure on the walls of the container. You can see that the pressure is proportional to number of collisions per unit area. Kinetic gas equation, it is an equation for pressure. Kinetic gas equation. Kinetic gas equation. It is an equation. Kinetic gas equation, it is an equation for pressure. Equation for pressure exerted by a gas, pressure exerted by an ideal gas on the walls of a container, pressure exerted by a gas, and the equation is given by, the kinetic gas equation is given by, kinetic gas equation is given by, this is the relation. Very carefully remember, the pressure exerted by a gas on the walls of the container is equal to 1/3 mn URMS square divided by capital V. Very importantly, let us see, we can easily derive the relation, and we are not going for the derivation. எப்படி derive ചെയ്യും? இந்த மாதிரி ஒரு gas system എടുക്കുம்போது ഈ gas systemത്തിക്കുள்ளே molecules are coming and they are colliding here. Collide ചെയ്യുമ്പോൾ we want to find out pressure. Pressure എന്നാ force by area. Force is the rate of change of momentum, Newton's second law, rate of change of momentum. Initial momentum கண்டுபிடிச்சு final momentum கண்டுபிடிச்சதுக்கு அப்புறம் rate of change of momentum எடுத்து force கண்டுபிடிச்சு கொடுக்கும்போது, in the manner we can easily derive it, and we are not going for the derivation, and you do remember the formula. This is called a kinetic gas equation. Kinetic gas equation means it is an equation for pressure. Kinetic gas equation is an equation for pressure exerted by a gas on the walls of the container, and this is the pressure formula. P is equal to 1/3 mn URMS square by V. 1/1 we can just check it as. In that the pressure உங்களுக்கு P என்ன உங்களுக்கு தெரியும்? P is the pressure exerted by gas. Small letter m என்ன? Mass of one molecule. And then there capital N இருக்கு. Capital N என்ன? Number of molecules. Then capital V and the volume, and this is the terms in the expression of kinetic gas equation. So repeat and fix in your mind the relation, the kinetic gas equation, it is an equation for pressure, and it is P equal to 1/3 mn URMS square divided by V. And let us check this application of these relations. And now we want to find out kinetic energy. Next one is kinetic energy of one mole and one molecule we are going to calculate. Kinetic energy of one mole and kinetic energy of one molecule. The difference is kinetic energy of one mole, one molecule. So very carefully we have to handle the equations. One small change mattum and the So kinetic energy കണ്ടുപിടിക്കണമെന്നാലും see and the one more thing is here URMS എന്നൊരു term ഇருக்கு. URMS is called it is called RMS velocity, root mean square velocity. We will discuss what is root mean square velocity, and a type of average taking method. RMS velocity, not average velocity, is another type of single velocity. That is average velocity, single velocity. Very value more than one velocity irukkumbodhu one velocity, average velocity. And this is also RMS velocity, also a single velocity, and a method different. different. Okay, so RMS velocity, how to calculate, we will be discussing. See, this is kinetic gas equation, and using the kinetic gas equation, we are going to find out the kinetic energy of 1 mole of gas. So first one, kinetic energy of 1 mole, kinetic energy of 1 mole of gas. See, kinetic gas equation. Now entire thing is depend on kinetic gas equation. So the kinetic gas equation, what is kinetic gas equation? Kinetic gas equation is equation for pressure, P equal to 1 by 3 m mass of a molecule and n mn u rms square divided by v. This is kinetic gas equation. And then, see, using the kinetic gas equation, I am going to derive the expression for kinetic energy. See, for 1 mole, the condition is first we can give. For 1 mole of an ideal gas, 1 mole contain how many molecule? 1 mole of an ideal gas contain, 1 mole of a gas contain Avogadro number of molecules. Then for 1 mole, we have to change the kinetic gas equation. எப்படி அது change ஆகும்? 1 by 3 into m into capital NA Avogadro number for 1 mole, then into URMS square divided by V. உங்களுக்கு தெரியும் யாரு m into NA, அது யாரு m into NA, mass into Avogadro number, that is called molar mass of 1 molecule into Avogadro number is called molar mass. So P is equal to 1 by 3 into capital M into URMS square divided by V. See, we need kinetic energy. Kinetic energy na half mv square, mass velocity square in the இடத்திற்கு, ஆனா half அந்த number இருக்காது. So just I am substituting 2 in denominator and numerator. So இந்த இடத்து this half mv square உங்களுக்கு இந்த இடத்து தெரியும், அது யாருன்னா அது kinetic energy. So take the remaining thing the left side, அது leftல் போகும்போது அது எப்படி வரும்? So 3 will be coming, 3 p இந்த இடத்து actually இருக்கா, ஆனா v வரும்போது 3pv divided by 2 is equal to half m u rms square, who is half m u rms square, that is kinetic energy. That is kinetic energy expression is kinetic energy nu mattum ezhudhiya pora, and eduthe you have to specify it, kinetic energy of 1 mole, kinetic energy of 1 mole is equal to 3 by 2 pv, 3 by 2 pv, one relation. And more than that, உங்களுக்கு தெரியும் ideal, for 1 mole of an ideal gas, PV is equal to, normally PV equal to nRT, and 1 mole வரும்போது PV equal to RT. So very important, very important, fix in your mind, kinetic energy of 1 mole of gas, kinetic energy of 1 mole of gas is equal to 3 by 2 PV के बदला RT. Kinetic energy of 1 mole is equal to 3 by 2 RT is the expression for kinetic energy of 1 mole, 3 by 2 RT. So a heading one more thing is pending there. Kinetic energy of 1 mole we calculated 3 by 2 PV or 3 by 2 RT, 3 by 2 PV or 3 by 2 RT. Fine. Then kinetic energy of 1 molecule. Let us consider kinetic energy of, see, kinetic energy of 1 molecule, kinetic energy of 1 molecule. So how we have to find out? உங்களுக்கு தெரியும் kinetic energy of 1 mole, we have 1 mole கேஸுக்குள்ள எத்தனை molecule இருக்கா? 1 mole of an ideal gas contain Avogadro number of molecule. அப்ப இதுக்குள்ளே Avogadro number of molecules இருக்கு, Avogadro number of molecules. So kinetic energy of 1 mole divided by Avogadro number is equal to kinetic energy of 1 molecule. Because ஒரு molecule 1 molecule எத்தனை molecules இருக்கா? Avogadro number of molecules. So a single molecule ஓட kinetic energy of 1 molecule is equal to kinetic energy of 1 mole, we have 3 by 2 RT divided by NA. You know that who is this NA, R by NA, universal gas constant divided by Avogadro number, that is Boltzmann's constant. So kinetic energy of 1 molecule kinetic energy of one molecule is equal to 3 by 2 R by Na ke badala Kb, Boltzmann's constant, Kb into T. This is kinetic energy of one molecules. Even derivation, everything you leave it, but fix the relations in your mind. So I am summarizing, I am concluding. This is our conclusion. We calculated kinetic energy of 1 mole. Kinetic energy of 1 mole is 3 by 2 RT. Then kinetic energy of one molecule is not 3 by 2 RT. Kinetic energy of one molecule is kinetic energy of one molecule is 3 by 2, not R3, RT, it is Kb into T. So this is the relations. Kinetic energy of one mole and the kinetic energy of one molecule. Fine, one molecules. Now let us check some problems. Okay, fine. So here we have a question. Let us check the questions. At a constant volume, temperature is increased. At a constant volume. So given data we can write at a constant volume fixed constant. Fine, given in the question. And temperature is increased. And then 4 statements are given. Collision on wall will be less on statement. Number of collisions per unit time will increase. Then collisions will be in a straight line. Then collisions will not change. These are the options. See, volume constant we want to find out number of collisions. Collision in the question, how logically we have to approach the problem. See, gas system gas ideal gas equation conclusion PV equal to nRT. We know that PV equal to nRT. Volume constant N and R already constant, fixed constant, N and R, and volume already in the constant in the question. That is why every time I am telling அந்த கொஸ்டினுக்குள்ளே ஒரு 50% ஆன்சர் கண்டிப்பாக அந்த இடத்துல இருக்கும். அது we have to read it in our whole heart mind, கரெக்ட் கான்சன்ட்ரேட் பண்ணி அதை ரீட் செய்யும்போது டெஃபினட்டாகவே we will get the idea. அப்போ வால்யூம் கான்ஸ்டன்ட்னா கண்டிப்பாக இந்த மாதிரி எழுத முடியும். ப்ரெஷர் இஸ் டைரக்ட்லி ப்ரொபோர்ஷனல் டு temperature. So temperature is increased in the question. Temperature is increased. Definitely temperature increase it is directly proportional to pressure. Temperature increase na pressure also increases. Pressure come back our postulates of kinetic theory edukumbo. See, we have the pressure is due to number of collisions per unit area per unit time. Our pressure increase anana adoda meaning pressure increase and the number of collisions per unit time will definitely increase. So that postulates are very important. That's statement. So this is the case. So pressure increase and the meaning pressure is due to one of the postulates of kinetic theory of gas. Pressure increase and kandipa number of collisions will increase. Number of collisions per unit time will increase. So the correct answer is second option is the correct answer. Number of collisions per unit time will increase. Okay, fine. So then another one question. Check the next question. Kinetic energy per unit volume is given as E. Not kinetic energy. Given kinetic energy per unit volume. Kinetic energy per unit volume is E. That is why I am telling, reading the question. So இது மாதிரி கரெக்டாகவே கொஸ்டின் ரீடு செய்யனா, so that is the success of the problem. Correctly, if you are reading and getting the correct information, correctly we are correlating. Scientifically, if you are moving, scientifically approaching physics la oru problem andha madri difficult problem avadhu. Okay, so very calm and quiet in a cool manner we have to approach the problems. Our attitude and our approach is the main thing. Okay, so kinetic energy per unit volume இந்த இடத்து E என்று கொடுத்திருக்கா. Fine. Then the pressure exerted by the gas, that is the question. I identified the problem. Pressure கண்டுபிடிக்கணும். So P We read the question, and we identified the question. This is the things. Pressure, we want to find out pressure. Think it, logically think it. Proposal of a theory, second part. Identification of the problem, first part over, reading over. Second one is proposal of a equation or a theory. When we are complete reading, there should be one relation in our mind. Okay, what is the relation there in your mind to solve the problem? What is the relation there? See, pressure, kinetic energy. Just we discussed the kinetic energy. Kinetic energy of 1 mole, not a molecule. Kinetic energy of 1 mole. Molecule anna 3/2 kT. And kinetic energy of 1 mole anna 3/2 RT എന്നെഴുതിയാലും പോതും. RT okay, kinetic energy 3/2 RT. Alana, for 1 mole of a gas, RT ki badala we can give PV. Fine, because pressure kandupidikkanam. So quite logic. Pressure including relation we selected. Fine. So we need E enna represent panniya yara E ennu koduthirukke and edathu. Kinetic energy is not E. Kinetic energy per unit volume. So take this volume in the left side. And the madri volume kondu varumbodhu how it will change? Kinetic energy per volume is equal to 3/2 P ennu varum. இந்த மாதிரி வரும். ஓகே, கரெக்டானா? அப்படின்னா இந்த மாதிரி இந்த ஆளை kinetic energy per unit volume can be replaced by a symbol E. E is equal to 3/2 P. But we want to find out the pressure P. That is our real question. So the conclusion answer P is equal to 2E divided by 3. 2E/3 is the correct answer. Okay, so which option is correct? Okay, 2E/3. Second option is correct one. 2E/3. 2E/3 is correct option. Fine. So then about RMS velocity of gas molecule. Kinetic gas equation எடுத்தபோது அந்த இடத்துல ஒரு term இருக்கா, RMS velocity ன்னு ஒரு term இருக்கா, RMS velocity. So we are just going to discuss RMS velocity. Fine. Okay, RMS velocity. Let us check about the meaning and the relation. Not too much of derivation, nothing, just the meaning. RMS velocity. Root mean square velocity. This is the meaning. RMS velocity. See, normally ഒരു ഗ്യാസ് സിസ്റ്റം എടുക്കുമ്പോൾ അതുക്കുள்ளே ധാരാളமாக molecules ഇരിക്കും. So first molecule, it is moving with the velocity v1. Second molecule, it is moving with the velocity v2. Velocity is a vector quantity having both the magnitude and the direction. So different direction, molecule v3, v4, they are moving in different direction, n number of molecules. And sometimes when you are taking normal average, some of the velocity terms will be positive, some of the terms will be negative. There is a possibility that when you are taking normal average, there is a possibility that answer can be 0. Equal value of positive and negative வரும்போது average எடுக்கும்போது there is a chance of 0. So இந்த மாதிரி வரும்போது எதுக்கு ஒரு சிங்கிள் வேல்யூ? சி, இந்த இடத்து v1 v2 v3 v4 வெலாசிட்டி எல்லாம் இருக்கு. ஆனா கேஸ் சிஸ்டத்தோட வெலாசிட்டி പറയുம்போது we need a single velocity. சிங்கிள் வெலாசிட்டின்னு கேட்கும்போது உங்களோட மைண்டுக்குள்ள வருന്നത് ஃபர்ஸ்ட் தாட் ஆவரேஜ் வெலாசிட்டி. ஃபைன், குட். ஆவரேஜ் வெலாசிட்டி எடுக்கும்போது 0. ஆனா சிங்கிள் வெலாசிட்டி கண்டுபிடிக்க இனி ஒரு மெத்தட் கூட இருக்கு. அது என்ன மெத்தட்? RMS. That is called RMS velocity. See, இந்த ப்ராப்ளம் சால்வ் பண்ணணும்னா நெகட்டிவ் ஆன வேல்யூ கூட பாசிட்டிவ் ஆக்கி மாற்றணும். அப்படி மாற்றணும்னா நமக்கு தெரியும் எந்த எடுத்தா போதும், ஸ்கொயர் எடுத்தால் போதும். ஃபர்ஸ்ட் ப்ராசஸ் I took the square of the velocity. So all velocity become positive. Now I am happy. Because velocity positive ஆனா கண்டிப்பா இனி ஆவரேஜ் எடுக்க முடியும். So second one positive value மட்டும் இருக்கு. So I am going to take the mean value. Fine, மீன் எடுத்திருக்கு, ஆனா ஸ்கொயரோட மீன் எடுத்திருக்கு. I want to neutralize it. அப்படியானா அது ஒரு ரூட் எடுத்தால் போதும். அப்போ அது மெயின்டைன் பண்ண முடியும். ஸ்கொயர் எடுத்ததுக்கு அப்புறம் மீன் எடுத்து, ஸோ அதை நியூட்ரலைஸ் பண்ணணும்னா ஒரு ரூட் எடுத்து. இது மாதிரி எடுக்கும்போது, இந்த மாதிரி ப்ராசஸ் நடக்கும்போது அதுக்கு எண்ட் ப்ராடக்ட் ஒரு சிங்கிள் வெலாசிட்டி. தட் வெலாசிட்டி இஸ் கால்டு RMS velocity, root mean square velocity. അപ്പം root mean square velocity യുടെ പ്രൊസീജിയർ എന്ന ഇൻഡിവിജ്വൽ വെലോസിറ്റീസ് ഇരിക്കുക, അതോടെ സ്ക്വയർ. ഫസ്റ്റ് v1 സ്ക്വയർ, v2 സ്ക്വയർ, v3 സ്ക്വയർ, എക്സെട്രാ vn സ്ക്വയർ. So first process I took the square. all values positive, comfortable, then I am taking mean edukanona plus then divided by total number. Mean also I took it என்னன்னா total number. Then final process root எடுத்த போது I will get a single value of velocity. That single velocity is called URMS, RMS velocity. RMS velocity, it is defined as the square root of mean of squares of all the individual velocities of molecules in a gas system at a particular temperature. Okay, so this is the RMS velocity. It is defined as the square root of mean of squares of all the individual velocities of molecules in a gas at a particular temperature. This is the thing. So, இது one general equation. I want to develop a specific equation for this RMS velocity that we will be developing from. That equation I am going to developing from kinetic gas equation. So I am going to derive just the RMS velocity. அது கண்டுபிடிச்சதுக்கு அப்புறம் average velocity, most probable velocity, இதோட எல்லாம் ஒரு tricky method we can fix the relations. RMS velocity அதோட formula URMS. இது எல்லாமே depending on kinetic gas equation. ഈ chapterோட core point, அந்த core area kinetic gas equation. What is kinetic gas equation? Pressure. Kinetic gas equation is equation for pressure. P is equal to 1/3 mn URMS square divided by V. இந்த இடத்திற்கு RMS velocity. So that velocity we want to calculate. So I am checking for 1 mole of an ideal gas. For 1 mole of an ideal gas, it contains Avogadro number of molecules. Then pressure P can be written as 1/3 m into Na into URMS square divided by V. And P is equal to 1/3 into உங்களுக்கு தெரியும் m into Na na. So many places it is coming mass of one molecule into Avogadro number, molar mass capital M into URMS square divided by V. In the இடத்துல we want to find out RMS velocity. Very simple relation. URMS is equal to URMS square first எடுக்கும்போது 3 அந்த இடத்துல left போய் P அந்த இடத்திற்கு V also there divided by M. ஆனால் உங்களுக்கு தெரியும் for ideal gas PV equal to RT ன்னு. அப்போ URMS square is equal to 3RT divided by M. So our final answer URMS equal to root of 3RT divided by M. RT by M. Very important relation. RMS velocity URMS equal to 3RT by M. அந்த இடத்து T temperature, R gas constant, M is the molar mass. Okay, fine. So 3RT by M. ஆனா இனி one more equation கூடி லாஜிக்கலாவே உங்களுக்கு இந்த இடத்துல டெவலப் பண்ண முடியும். ஏன்னா அது 3 into எந்த இடத்து capital M மாறி small letter M வரும்போதும் already I informed small letter M வரும்போ ஒரு சேஞ்ச் இருக்கா, 6 மாறி will KB Boltzmann's constant into T. So this is also the another equation. In terms of capital M, RMS velocity root 3 RT by capital M or root 3 KBT by M. In one more relation we can just develop and we can finally conclude. Pressure equation உங்களுக்கு தெரியும். Pressure P is equal to pressure density. இந்த சாப்டரோட ஸ்டார்டிங்கில் நம்ம டென்சிட்டிக்கு ஒரு ரிலேஷன் டிரைவ் செய்திருக்கு. டென்சிட்டி rho is equal to the first starting process will we have a develop an equation for density. What is the equation for density? In the இடத்திற்கு two relation PM divided by RT, P capital M divided by RT. So density க்கு பதிலா we can give the value density is equal to rho equal to P capital M divided by RT. அந்த மாதிரியான இந்த இடத்தை RT by M ന് ബദലാ here ഒരു RT by M இருக்கு, അതിന് ബദലാ one more relation RT divided by M is equal to RT by M equal to P by rho എന്ന് എഴുതിയാൽ പോലും P by rho. അപ്പോൾ in terms of pressure URMS one more relation root of 3 RT by M ന് ബദലാ P by rho. So this is the same. So we are concluding even derivation you can just avoid and then fix the relations in your mind. What is the relation? Root mean square velocity. Root mean square velocity. Three relations, one by one relations. URMS equal to root 3 RT divided by capital amount relation is equal to root 3 KBT divided by smaller train one relation, also root 3 P by rho, another equation. This is the relation for RMS velocity. Root means square velocity. Fine. Then about next we have to discuss one question. This is the question problem. At what temperature? At what temperature is the root mean square velocity of gaseous hydrogen molecule is equal to that of oxygen molecule at 47 degrees Celsius? At what temperature root mean square velocity? Question reading important first thing. So at what temperature? At what temperature? At what temperature? RMS velocity, RMS velocity of gaseous hydrogen. At what temperature? தெரியாத temperature கண்டுபிடிக்கணும். At what temperature this RMS velocity of gaseous hydrogen molecule is equal to that of oxygen molecule. RMS velocity of oxygen molecule at a temperature 47 degrees Celsius. At a temperature 47 degrees Celsius. It is given. It is given. This is the condition. In the temperature கண்டுபிடிக்கணும். RMS velocity just we discussed. 3 formula இருக்கா. ஆனா temperature include செய்து வருന്ന formula molar mass, molecular mass இருக்குന്ന formula. You know that what is the RMS velocity? URMS equal to the first derived relation 3 RT divided by capital M. Temperature America, molecular mass America. So you have to substitute the value URMS of hydrogen. Hydrogen order molecular mass MH is equal to 2 gram. 2 into 10 raised to minus 3 kilogram. 2 into 10 raised to minus 3 kilogram. And the molecular mass of oxygen. Molecular mass of oxygen very clear, 32 gram. 32 into 10 raised to minus 3 kilogram. Standard unit convert ചെയ്തിരിക്കുക. Now substitute the value root 3 RMS velocity na root 3 RT temperature கண்டுபிடிக்கணும் தெரியாது divided by M. Mass na mass of hydrogen 2 into 10 raised to minus 3 is equal to root 3. Then comes root 3 RT. Temperature, oxygen's temperature given 47 degrees Celsius. 47 degrees Celsius na Kelvin like convert cheyumbo that will be equal to 27 room temperature na 27 degrees Celsius na 300 Kelvin plus 273. Appo 47 plus 273 it will be equal to 320. It will be equal to 320 divided by 32 molar mass minus 3. See root എല്ലാം cancel ചെയ്ത് 3R എല്ലാം cancel ചെയ്ത് 10 raised to 3 10 raised to minus 3 cancel ചെയ്തെടുക്കുമ്പോൾ T by 2 is equal to 320 divided by 32 which is equal to 10. Therefore temperature, at which temperature RMS velocity of gaseous hydrogen will be equal to RMS velocity of oxygen at 47 degrees Celsius? That temperature is 20 Kelvin. So the correct option is first option, 20 Kelvin is correct answer. Okay, fine. Then average velocity is simply the arithmetic mean. The molecule எடுக்கும்போது அந்த molecule 1 by 1 molecule எடுக்கும்போது velocity v1 v2 v3 individually velocity இருக்கு. அப்ப average velocity கண்டுபிடிக்கணும்னா v average is equal to just the arithmetic mean of all the velocities of individual molecules at a given temperature. Okay, so we are simply taking the arithmetic mean v1 plus v2 plus v3 plus n molecule irundal n velocity இருக்கும்போது vn divided by n. This is average velocity. ஆனா இந்த இடத்து one more formula I am writing v average. உங்களுக்கு urms velocity தெரியும். URMS or VRMS ன்னு கொடுத்தாலும் போதும். RMS velocity க்கு 3 equation. There are 3 equations for RMS velocity. One by one equation, recollect it. URMS equal to what is the first one? Root. The repeat ചെയ്ത് உங்களோட மனசு மைண்டிலே ஃபிக்ஸ் பண்ணி இருக்கணும். Okay, root 3 RT divided by capital M is equal to root 3 M മാറി small letter M ആകുമ്പോൾ R മാറി KB into T equal to root 3 P by D. These are the three relations. Average velocity ക്ക് ഇതിൻ്റെ അടുത്ത് ഒരു ചിന്ന ചേഞ്ച് മറ്റും വന്നാൽ പോതും அந்த 3 ഇരിക്കുന്നിടത്ത് 8 by pi എന്ന നമ്പർ പ്ലേസ് ചെയ്താൽ പോതും. ബാക്കിയെല്ലാം സെയിം. 8 by pi RT divided by capital M is equal to 8 KBT divided by small letter m is equal to root 8 P by root 8 P by pi d. So this is the equation for average velocity. ഒരു small change, RMS velocity we derived, correct? derived அந்த ஃபார்முலா இருக்கு, அதுக்குள்ள 3 எந்த இடத்துல எடுத்து ரீப்ளேஸ் பண்ணியதுக்கு அப்புறம் யாரை ப்ளேஸ் பண்ணியிருக்கா 8 by pi வச்ச போது similar 3 equation we got it. Then about last one, most probable velocity, RMS velocity, average velocity, and last one is called the most probable velocity. Most probable velocity na see ஒரு gas system எடுத்த போது total see அதுக்குள்ள 15 molecules இருக்கா அதுக்குள்ள உள்ள 10 molecules possess a velocity, 10 molecules having same velocity 5 meter per second. ஆனா அதுக்குள்ள உள்ள 2 molecules possess velocity 2 meter per second, and one molecule possess 1 meter per second velocity. About 13, and the remaining two molecules possess 10 meter per second velocity. இதுக்குள்ள யாரு most probable velocity? Most probable velocity na it is the velocity possessed by maximum number of molecules in a gas at a given temperature. ഒരു particular temperature എടുത്ത പോது அதுக்குள்ள maximum number of molecules 10 molecules possess 5 meter per second. So this 5 meter per second is called most probable speed or most probable velocity. So it is defined as the velocity possessed by maximum number of molecules of a gas at a particular temperature. So in that the 5 meter per second is called, it is called most probable velocity. And we are going to derive, just to write an equation for most probable speed. So I am just to recollecting the remaining relation. First RMS velocity உங்களுக்கு தெரியும், 3 equation definitely fix in your brain, definitely fix in your mind. 3 RT divided by capital M or equal to 3 KBT divided by small letter m is equal to root 3 P by rho density. And average velocity, average also we have just developed. 3 mighty 8 by pi vechal podum, 8 RT divided by capital M equal to 8 KBT divided by pi into small letter m is equal to 8 P divided by pi into rho 8. Then last one, we MPS, most probable speed. MPS or V, U or V symbol you can give, most probable speed. About 3 மாற்றி 8 by pi வச்ச போது average velocity we can, this is only for fixing the relation in your mind. Okay, fine. Then 3 மாற்றி 2 வைக்கும் போது relation will be for most probable speed, that is root 3 க்கு பதிலா 2 வைக்கும் போது 2 RT divided by capital M is equal to root 2 KBT divided by small letter m is equal to root 2 P divided by rho, root 2 P divided by rho. So this is the 3 relations for RMS, average, and most probable speed. So what's the relation we can write here? Very important relation. URMS is to just take a ratio, URMS is to U average is to U most probable speed equal to இந்த இடத்து எல்லாம் 3C RT by M இருக்கு. அப்போ ரேஷியோ எடுக்கும்போது root 3 is to root 8 by pi solve ചെയ്യുമ്പോൾ you will get 2.5 is to root 2. So which one is greater? So URMS greater than U average greater than U most probable speed. Correct. So do remember all the relations. So randomly we have to use these relations for solving problems. And this is the relation between RMS average and most probable speed. Most probable speed. So then about mean free path. Just a one thing, mean free path. Our time is very close. Okay, then just we can discuss one more topic, that is called a mean free path. Mean free path. Mean free path na see ഒരു ഗ്യാസ് സിസ്റ്റം എടുക്കുമ്പോൾ let us consider a gas system here. And இதுக்குள்ள தாராளமா molecule இருக்கு, தாராளமா gas molecules இருக்கு. See இந்த மாதிரி இருக்கு. இந்த இடத்திருக்கிற ஒரு molecule இந்த மாதிரி மூவ் செய்து இந்த இடத்து வரும்போது it will collide with the molecule. அந்த மாதிரி collision நடക്കുന്നதிന് முன்னாடி it traveled a path I represented as lambda 1. That is called a free path. Free path, not a mean free path, simple free path. And again it is moving and it is colliding with another molecule. Then there is a free path lambda 2. Another movement before next collision, another path lambda 3. So this one lambda 1, lambda 2, lambda 3 all are called free path. They are called a free path. Our mean free path na quite logical, very logical. Mean free path na mean free path lambda m and denote panna இந்த இடத்துல lambda m. ഈ പാത്തോட ആവറേജ് എടുത്താൽ പോലും mean free path lambda 1 plus lambda 2 plus lambda 3 plus etc plus lambda n divided by n. This is called mean free path. And mean path free path in a specific relation you have to fix the relation in your mind. Mean free path lambda m is equal to 1 by root 2 n pi d square. Very important relation. What is the relation? Mean free path general equation, okay, lambda m, okay, equal to lambda 1 plus lambda 2 plus lambda 3 plus etc plus lambda n by n. Free path எல்லாம் எடுத்ததுக்கு அப்புறம் அதோட average எடுத்தா போதும். So mean free path actually it is the average distance. Different distance இருக்கு, அதோட average. The average distance traveled by a gas molecule between two successive collisions. The average distance traveled by a gas molecule between two successive collision is called which path? Mean free path. Mean free path. And this is the specific relation for mean free path. Lambda m is equal to 1 by root 2 n pi d square. அதுக்குள்ள இருக்கிற ஒரு 1 by 1 terms you just write. Lambda m na உங்களுக்கு தெரியும் mean free path. Mean free path. Okay. Then about n. N is not a number of molecules. Very importantly, not down. N is called a number density, or it is called a number of molecules. Number of molecules per unit, number of molecules per unit volume, or it is called a number density. Number of molecules per unit volume. So number of molecules per unit volume is small letter n. Then about and the d endirukku. D is the diameter of a molecule. D is the diameter of molecule. So ஒரு equation வரும்போது அதுக்குள்ளே உள்ள each and every character we should be familiar. Lambda n mean free path equal to relation. What is the relation? 1 by root 2 n pi d square. N is the number of molecules per unit volume. D is the diameter of the molecule. Fine. Then we can check one question here. Let us find out the question. This is the question. Calculate the ratio of mean free path of molecule of two gases. Mean free path கண்டுபிடிக்கணும். Mean free path of two molecules. So the first molecule mean free path lambda 1. Second one you can take lambda 2. This ratio we want to find out. Lambda 1 by lambda 2. Okay. So if the ratio of the number density per centimeter cube, number density na n1 is to n2 given in question. That number density. What is number density? It is given as 5 is to 3 എന്ന് കൊടുത്തിരിക്കുക. And the ratio of diameters, diameters of the molecules, that is d1 is to d2 is given as 4 is to 5. See, this is the relations and we want to find out. See the same pattern I am following, correct Anna? Just reading the question, just writing the things and just applying. Actually idu oru problem solving enna, idu oru art. art, and the person doing that work is called an artist. So try to become good artist. Okay, so either gaming madri edukumbodhu physics will be more and more simple for you people. Fine, lambda 1 by lambda 2. Let us check. Mean free path ode relation நமக்கு இப்ப தெரியும். It is 1 by root 2 n pi d square. Fine, okay. 1 by root 2 n pi d square. D யாரு? D என்ன? Diameter of the molecules. Okay, fine. அப்படியானா இது lambda proportional to root 2 number pi number. Okay, fine. Then 1 by n d square ன்னு மட்டும் எழுத முடியும். கரெக்ட் ஆனா? Fine. Okay. So இந்த மாதிரி இருக்கு. அப்படியான lambda 1 by lambda 2 we can just calculate within a fraction of time. Lambda by lambda 1 by lambda 2 is equal to see here it is in denominator. Correct? Correct? N and D is both are in denominator. So lambda 1 by lambda 2 வரும்போ just reverse. That is n2 d2 square divided by n1 d1 square. Solved. Reading of the question. Then proposal of a equation or a theory, and we are going to test it. How to test? Give the values. Lambda 1 by lambda 2 is equal to, what is n2 here? N2 3 into what is d2 5 square, all divided by what is n1 5 into 5 into where is d1 here 4 square. So solved. 1 5 cancelled. So 3 into 5 and 15 divided by 16. So such an option is here. Fine. Second option correct. 15 is to 16. Okay, okay. So this is the so right now the time is 8 o'clock sharp. 8 o'clock. You see, we won't be able to finish the complete section chapter. So if time permits, we will meet again. So here I am concluding. Here is your SRT from Kerala NEET Academy. Thank you. Bye.